For a long time, Pluto was considered simple, cold, inactive, a distant remnant of the solar system's childhood, circling silently at the edge, with nothing new left to tell us. This idea was comfortable. Pluto was far enough to ignore, small enough to underestimate, cold enough to assume that nothing could still be happening there. For decades, it fit neatly into our expectations. When the New Horizons spacecraft began its journey, the mission was not framed as a gamble. It was not meant to overturn paradigms. It was a final look, a quiet visit, a respectful goodbye to a former planet. Scientists expected confirmation, old models, a surface scarred by craters, a world frozen in time. No one expected resistance. No one expected contradiction. But that is exactly what appeared. From the first data sets, something felt wrong. The shapes did not match. The structures looked too organized, too smooth, too young. Entire regions showed almost no impact craters, surfaces that on cosmic timescales appeared surprisingly recent, as if time itself had been erased. And then an uncomfortable question emerged, one that few were ready to voice. How is this possible? Pluto is small. Its internal heat should have faded billions of years ago. It lies far from the sun. External energy sources are minimal. It is ancient, far too ancient to still be changing. And yet, it was, not as a singular anomaly, not as a coincidence, but as a pattern. As more data arrived, the tension grew. Mountains made of water ice, rising kilometers high. Vast plains of nitrogen ice that appeared to flow slowly. A massive, heart-shaped region that even affects Pluto's rotation. Pluto did not behave like a passive object. It responded, it adjusted, it remained active. And none of this fit the existing framework, because all of it required energy. Not once, but continuously. Where could that energy come from? The question did not stop at Pluto. It spread outward, toward the far reaches of the solar system. If this small, cold, distant world could behave this way, what else had we misunderstood? Perhaps the problem was never Pluto. Perhaps it was the way we had learned to look at the universe. And this, quietly, was only the beginning. As the data continued to be examined, the initial surprise slowly transformed into unease. Not because of a single strange detail, but because of how consistently Pluto refused to behave as it was supposed to. The vast nitrogen plains did not look rigid. They showed structure, polygonal patterns, boundaries that pressed against one another as if the surface were organized from within. Such forms do not appear by chance. They are signatures of movement, of exchange, of matter responding over time. And this is where the real problem emerged. Movement requires energy, not once, not briefly, but continuously, across immense spans of time. Pluto is small. Its internal heat should have dissipated long ago. Known radioactive sources are insufficient. The sun is far too distant to provide meaningful external input. And yet, the surface appeared to be renewing itself. When scientists began estimating surface ages, the discomfort deepened. Regions with few craters were not rare. They were widespread, dominant. On planetary timescales, this implied youth. Not human youth, but geological youth. Millions of years. Perhaps less. For an object in the Kuiper Belt, this was astonishingly recent. And the same question returned, again and again. How can a world like this remain active for so long? Attempts were made to isolate each anomaly. Local conditions, unusual histories, edge cases. But with every added explanation, the overall picture became more fragile. Another element complicated things further. Pluto has an atmosphere, thin but dynamic. It freezes, it sublimates, It responds to extreme seasons, even though a single Pluto year lasts 248 Earth years. More importantly, this atmosphere interacts with the surface, not passively, as part of a system. That implies coupling, internal processes, surface behavior, and atmospheric cycles influencing one another. For a body of this size, this is extraordinary. And then there are the mountains. Mountains made of water ice, hard as rock at Pluto's temperatures, rising several kilometers high. Such structures cannot simply float. They require support, a solid crust or an interior that is not completely rigid. This opened an uncomfortable possibility. What if Pluto's interior is not fully frozen? For a long time, this idea was dismissed. Too small, too cold, too old. But now, it returned, not as a conclusion, but as persistent noise. The more Pluto was treated as an exception, the clearer another possibility became. Perhaps it is not an exception at all. Perhaps our expectations are the real limitation. We had learned to view small bodies as simple, as static archives of the past. Pluto did not behave like an archive. It behaved like a system, slow, subtle, but active. And systems have a troubling quality. They follow their own rules. If Pluto is a system, then a larger question emerges. What does this mean for the outer solar system as a whole? The Kuiper Belt is not empty. It contains thousands of known objects, and likely millions more unseen. If even a fraction of them exhibit similar dynamics, then our mental map is incomplete. Perhaps, for all this time, we have not been observing silence. We have been observing slowness. As the discussion deepened, it became clear that Pluto could not be understood in isolation. Each new interpretation pulled the outer solar system into focus. Because when all observations were placed side by side, the picture no longer looked accidental. Pluto did not simply show activity. It showed stability within that activity. Change that was not chaotic, but structured. And that distinction matters. Chaotic processes can be dismissed as rare. Stable processes point to underlying mechanisms. This is where the conversations became more careful. Not because ideas were lacking, but because every conclusion had consequences far beyond a single world. An uncomfortable question began to take shape. What if Pluto possesses a source of energy we have underestimated? What if that energy does not come from one process, but from a slow and persistent combination of many? Even considering this felt unsettling. Pluto has a large moon, Karen. The two bodies are gravitationally bound. They do not orbit a simple center, but revolve around a shared point. For years, this relationship was treated as a curiosity. Interesting, but largely inconsequential. Now, that assumption began to erode. Tidal forces generate energy, not explosively, but continuously. A small deformation, repeated over billions of years, can sustain internal motion. This idea alone was enough to raise concern. Because if it were true, Pluto was no longer an isolated block of ice. It was part of a dynamic system, and even this explanation felt incomplete. The activity was not evenly distributed. Some regions appeared younger, others more stable, as if Pluto's interior did not respond uniformly, but in layers. This hinted at structure, at differentiation, at complexity beneath the surface. Another detail reinforced this impression. Large surface features were not randomly oriented. They clustered in regions where long-term stability would be expected. This suggests something subtle but profound. Pluto does not merely change, it adapts. And adaptation is not a word traditionally associated with dwarf planets. The deeper the analysis went, the more uncomfortable the implications became. If Pluto functions this way, it cannot be unique. The Kuiper Belt contains thousands of known objects. Many have moons. Many are gravitationally coupled. If even a small fraction of them exhibit similar dynamics, then we are not looking at a graveyard. We are looking at a region defined by slow, persistent processes. This changes the entire perspective. The edge of the solar system no longer appears silent. It appears patient. But another problem quickly followed. Our instruments are designed to detect rapid change, clear events, obvious signals. Processes that unfold over millions of years are easy to miss. Perhaps we did not fail to see them because they were absent. Perhaps we failed because we did not know how to look. This thought is unsettling because it does not question Pluto. It questions our way of observing. And with that, our confidence in the completeness of what we think we know. The more this realization settled, the clearer it became. This was no longer a story about ice or geology or a distant dwarf planet. It was a story about how active a system can be, even where we assume energy does not exist. The central question remains unanswered, but the feeling intensifies. Pluto did not show us something isolated. It is preparing us for something much larger. At this stage, it became clear that adding new hypotheses was no longer enough. The older assumptions themselves had to be questioned, because the more the models were refined, the more a troubling pattern emerged. No single explanation worked on its own. Each theory fit one aspect, but strained another. This is a familiar warning sign in science. What made the situation especially unsettling was that none of the observed processes pointed to a single triggering event. There was no evidence of a recent impact, no sign of a sudden catastrophe. Everything pointed instead to long-term dynamics, slow cycles, repetition, adjustments that occur again and again without dramatic turning points. This kind of behavior does not belong to a dead world. And yet, according to our traditional categories, Pluto should be exactly that. Small, cold, ancient. Those categories had served us well for decades. Now, they began to fail. Attention inevitably shifted inward, not to specific details, but to underlying principles. What internal states could allow activity to persist for billions of years without rapidly exhausting itself? The question was uncomfortable because it forced a redefinition of what active really means. For a long time, geological activity meant heat, magma, extreme pressure. Pluto offers none of these. Instead, it presents transitions, redistributions, changes of state, ice that does not behave like ice, nitrogen that does not merely freeze but slowly flows, materials that, under extreme conditions, acquire unexpected properties. Accepting this requires abandoning Earth-based intuition, because we think of geology in terms of heat, violence, and speed. Pluto operates in a different regime. Slow, cold, persistent. And the more this idea took hold, the more unsettling another thought became. What if we are asking the wrong questions? What if Pluto is not showing us how a small planet behaves, but how a different kind of equilibrium works? An equilibrium sustained by time rather than by intense energy. This idea does not apply to Pluto alone. It extends to cold moons, to distant objects, to worlds we have catalogued but never truly interpreted. Perhaps they are not inactive. Perhaps they are simply slow. This shift in perspective changes everything, because it moves the boundary between active and inactive to an entirely new place. And moving boundaries create discomfort. They force revisions of language, models, and expectations. Pluto forces exactly that, and it does so quietly, without spectacle, without urgency, simply by behaving in a way that does not fit. In science, that is often how the most important changes begin. From this point on, the discussion could no longer remain purely technical. Not because data were missing, but because their implications were becoming too broad to ignore. Accepting that Pluto is active over long timescales forces another assumption into question: our relationship with time itself. For decades, we assumed that small worlds age quickly, that their stories end early, that what follows is erosion and silence. Pluto contradicts this narrative. The processes observed there are not fast. They are not violent. They are not dramatic. They are slow, persistent, patient. They point to timescales that lie far beyond human intuition, millions of years, tens of millions, perhaps more. And here the difficulty emerges. Our idea of activity is tied to events, to visible change, to clear disruptions. Pluto shows something different: change without events, transformation without climax. A form of dynamics that is easy to overlook, precisely because it does not announce itself. If we accept this logic, a different image appears. A world that does not live in a dramatic sense, but regulates itself. Not through heat, but through material properties, through phase transitions, through slow redistribution. It does not need fire. It does not need explosions. It only needs time. And time is exactly what Pluto has in abundance. This leads to another uncomfortable question. What if we are misinterpreting the ages of planetary surfaces? Our methods rely on impact rates, on statistics, on models developed for the inner solar system. The outer regions follow different rules. Fewer impacts, different materials, different dynamics. Perhaps a young surface there does not mean the same thing as it does near Earth. Perhaps it speaks less about age and more about renewal. If so, many timelines would need revision. And that is not a small problem, because chronology is the backbone of how we reconstruct the past. If it becomes unstable, everything built upon it trembles. Pluto does not force this conclusion, but it demands that we consider it, not as certainty, not yet, but as interference. Another aspect reinforces this unease: the chemical diversity of Pluto's surface. Different ices, complex mixtures, regional distributions that do not appear random. Chemistry is slow, but it is not passive. It responds to temperature, to pressure, to radiation. If these patterns persist, they imply stable conditions, an environment that does not collapse, but endures. This again contradicts the image of a dead world. Taken together, these clues form a picture that is difficult to dismiss. Pluto does not merely exist, it functions, not like a machine, not like an organism, but like a state of balance that sustains itself. And here, the tension shifts once more. Because if Pluto functions this way, it stops being a curiosity. It becomes an example that activity can take many forms, that dynamics do not require noise, that change is not always visible. Perhaps the universe is far more actively quiet than we have imagined. And perhaps, for that very reason, it took us so long to notice. The final explanation is still incomplete. There is no single mechanism that explains everything. But that is no longer the most important point. What matters is this: Pluto forces us to reorganize our understanding of time, of activity, and of stillness. And that reorganization has only just begun. By this point, something fundamental had shifted, not in the data, but in how the data were being understood. Pluto was no longer just an object to be explained. It had become a reference point, a reference against which the strength of our assumptions about the outer solar system could be tested. Because the more Pluto was forced into existing models, the more uncomfortable a pattern emerged. Those models only worked when reality was simplified. Processes had to be ignored, timescales compressed, interactions separated, even when they were clearly connected. Each simplification weakened the explanation. This is another warning sign. When a model survives only by trimming reality, the problem is rarely reality itself. Pluto made that impossible to ignore. Traditional categories began to fail. Small no longer meant simple. Cold no longer meant dead. Ancient no longer meant inactive. For a long time, those equations seemed reliable. Pluto quietly dismantled them, one by one. Not abruptly, not dramatically, but persistently. What made this especially unsettling was how little of Pluto's behavior could be treated in isolation. The surface, the atmosphere, the interior, they appeared to be coupled, not linearly, but through feedback. And feedback changes everything. Systems with feedback do not behave like collections of parts. They absorb disturbances. They compensate for imbalance. They find new stable states instead of collapsing. If Pluto functions this way, its subtlety makes sense. Why there are no explosions, why nothing suddenly stops, why activity continues without spectacle. It is integrated. And precisely because it is integrated, it is difficult to detect. Classical planetary science looks for clear signals, direct causes, immediate effects. Pluto offers none of these. It offers interaction, gradual adjustment, long-term coherence. This forces a change in perspective. The central question is no longer, what is happening here? It becomes, how is this maintained over time? That question is uncomfortable, because it brings planetary science closer to fields where control is limited and prediction is probabilistic. Climate, complex systems, self-regulation. Here, boundaries begin to blur, not between science and speculation, but between what we consider active and what we dismiss as inert. Pluto is not alive, but it is not still. It responds without urgency, without violence. The more this view settled, the more another question gained weight. How long has Pluto been functioning this way? Are we seeing the last echoes of activity, soon to fade? Or are we observing the normal state of cold worlds over billions of years? This question changes everything, because it determines whether Pluto is an exception or a misunderstood rule. There is no final answer yet, but the evidence points in an unsettling direction. This does not look like a system winding down. It looks like a balance, not an ending, but a condition. If that is true, then time itself must be reconsidered once more. Not as a countdown, but as a stabilizing frame. Perhaps the outer solar system was never truly quiet. Perhaps it was simply slow. And that slowness, mistaken for silence for so long, is what Pluto now forces us to recognize. Here the tension deepens, not louder, deeper. Because the question is no longer whether Pluto surprises us. The question is what this surprise says about our entire picture of the solar system. At this point, refining interpretations was no longer enough. Certain certainties had to be released, because the discussion had reached a threshold where Pluto could not be explained by small adjustments, not by added assumptions, not by convenient exceptions. The structure of the story itself began to fail. For decades, we told the history of the solar system from the inside outward. From rocky worlds, hot, energetic, dynamic. Everything farther away was treated as a weaker continuation, a colder afterthought, a system slowly winding down. Pluto does not fit that sequence. It does not behave like an epilogue. It behaves like a different chapter. This leads to an uncomfortable question. What if we have been telling the story from a single point of view? What if the outer regions are not simply slower versions of the inner system, but a different regime altogether? A cold regime, yes, but not an inert one. This idea had lingered at the margins for a long time, not because it was implausible, but because it destabilized order. Accepting multiple evolutionary logics means giving up the comfort of a single timeline. One fast, hot, violent logic close to the sun, and another, slow, cold, persistent logic farther out. Pluto clearly belongs to the second, but that does not make it secondary. It makes it representative. If this logic is valid, then Pluto is not a rare exception, but an example of an entire class of worlds. Worlds whose activity does not appear as explosions, but as stability. Not as events, but as processes. This reverses our expectations. For a long time, we equated activity with intensity, with speed, with spectacle. Pluto demonstrates that activity can be quiet, that it can unfold on timescales that resist intuition. And here, a deeper problem emerges. Our instruments, our models, our language are optimized for the fast, for the visible, for the immediate. Slow systems fall out of focus, not because they are absent, but because we do not know how to read them. If Pluto operates this way, then we did not overlook it due to lack of data. We overlooked it due to lack of perspective. This realization is unsettling, because it does not challenge a planet. It challenges a method. How many processes have we dismissed simply because they do not fit within our observation windows? How many worlds have we labeled dead when they were only slow? These questions offer no quick answers, and that is precisely why the tension deepens. They suggest we are standing at the edge of a perspective shift. Not abrupt, not dramatic, but profound. Pluto forces a redefinition of activity, not as exception, but as adaptation. Cold does not eliminate dynamics, it transforms them. Size does not limit complexity, it changes scale. Distance does not imply irrelevance, it implies different rhythms. All of this leads to a provisional conclusion, as uncomfortable as it is unavoidable. We have not fully understood Pluto. Pluto has shown us that our understanding was incomplete, and that recognition marks the beginning of a new phase. Not one of answers, but of better questions. Because once we accept that multiple forms of dynamism exist, there is no return to a single, linear story. The solar system stops being a timeline. It becomes a mosaic, and Pluto, far from the edge, reveals itself as one of its key pieces. At this stage, the tension could no longer be sustained by questions alone. The discussion needed to move closer to its core without revealing it all at once. What was beginning to emerge was not a single anomaly, but a principle that had remained hidden not because of missing data, but because of missing perspective. For a long time, planetary activity was assumed to depend almost entirely on heat, on concentrated energy, on extreme gradients. Pluto satisfies none of these conditions, and yet it changes. This forced attention to shift away from energy itself and toward the behavior of matter. Not what matter is, but how it responds under extreme conditions. On Pluto, the main actors are not molten rock, but volatile substances. Materials that, at extremely low temperatures, do not behave as we expect. Nitrogen, methane, carbon monoxide. On Earth, these are rarely considered geological agents. On Pluto, they take center stage. These materials do not require intense heat to generate motion. They respond to small variations, subtle changes in temperature, minor differences in pressure. Repeated over millions of years, these changes accumulate. Not violently, not quickly, persistently. Here, an unsettling idea takes shape. Pluto's dynamics do not depend on energy peaks, but on transitions, on phases, on states, solid becoming soft, soft beginning to flow, material redistributing, then freezing again elsewhere. Not as an event, but as a cycle. This is not yet a complete explanation, but it is no longer a collection of coincidences. It begins to resemble a pattern, and patterns are dangerous because they demand generalization. If this kind of behavior is possible on Pluto, then it may be possible on other worlds with similar conditions. We are not talking about volcanoes, not about obvious subsurface oceans. We are talking about something quieter, a form of activity that feeds on stability, not extremes. This helps explain why surfaces can appear young without destruction, why mountains can persist without magma, why landscapes evolve without catastrophe. But it also introduces a deeper consequence. If such processes are real, then our definition of activity has been too narrow. We have searched for loud signals, clear events, rapid transformations. Pluto suggests that some of the most important dynamics are silent. And here, the intrigue intensifies, because accepting this possibility forces another admission. Many of the solar system's quiet regions may not be quiet at all. They may be active, but at a rhythm we do not recognize. This thought offers no comfort. It does not simplify the picture. It complicates it, because it implies that the universe may be filled with processes we have never learned to read. Pluto does not yet give us a final answer, but it no longer allows the comfort of old explanations. It places us in an in-between space, where something begins to make sense, but cannot yet be closed. And that space, between understanding and uncertainty, is often where science changes direction. At this point, the intrigue can begin to settle. Not into a simple answer, but into a principle that brings order to what we have seen. What appeared on Pluto was not hidden heat, not a secret engine, not a statistical anomaly. It was motion driven by phase transitions. Under extreme cold, certain materials do not behave as rigid solids. They do not remain fixed. They exist close to boundaries between states. Nitrogen, methane, and carbon monoxide can shift between solid, soft, and flowing states, with very small changes in temperature or pressure. On Pluto, those variations are subtle but constant. Seasons that last decades. An orbit that slowly alters sunlight. Tiny differences that, accumulated over millions of years, produce profound effects. When material expands, it exerts pressure. When it contracts, space opens. When it begins to flow, even slowly, the surface reorganizes. This does not happen once. It happens continuously. Across vast spans of time, these cycles generate motion. Not violent, not explosive, persistent. This explains why nitrogen planes appear renewed, why young surfaces do not require catastrophe, why landscapes evolve without dramatic scars. There are no volcanoes. There is circulation. There are no eruptions. There is redistribution. This dynamic is also linked to Pluto's atmosphere. When volatile ices sublimate, the atmosphere thickens. Pressure shifts. Material is transported. When it freezes again, it settles elsewhere in a new configuration. A cycle forms. Not a biological cycle, but a material one. And this cycle does not need intense heat. It needs time. Here, a crucial realization emerges. Geological activity is not necessarily tied to energy abundance. It is tied to the possibility of changing state. Where matter can transform, dynamics are possible. Pluto possesses this potential in abundance. That is why its surface does not age as expected, why craters do not accumulate endlessly, why no final frozen form is reached. Instead, the surface adjusts. This mechanism does not act alone. It is coupled to gravity, to rotation, to interaction with Charon. Each element contributes to keeping the system away from absolute rest. And here, the conceptual turn becomes clear. Pluto is not active despite being cold. It is active because it is cold. Because cold allows these materials to exist at the edge of transformation. This idea feels counterintuitive, but it fits the data. And by fitting, it organizes everything that came before. The anomalies stop being anomalies. They become consequences. We are not looking at a special case. We are looking at a different regime, a regime of cold dynamics. This does not mean all cold worlds behave the same, but it means many of them can no longer be assumed static. The implications extend far beyond Pluto. They force a redefinition of what we mean by activity, not as something loud, but as something continuous, not as an event, but as a process. This was the moment many scientists realized they were not witnessing the end of a story. They were witnessing the emergence of a new category, a category that had no name, simply because we did not know it existed. Pluto was the first place where this dynamic became visible, not because it is unique, but because it was observed at the right moment, with the right instruments, and with new questions. That, more than any single image, is what truly shocked the scientific community. Not the mechanism itself, but the certainty that we had been looking without seeing. And once something is seen, it cannot be unseen. Once this principle becomes visible, its consequences begin to spread outward. They do not stop at Pluto. They cannot. Because if cold dynamics are real, then Pluto is not an isolated case, but a signal pointing toward an entire region of the solar system that we have underestimated for decades. The Kuiper Belt no longer looks like a storage zone of frozen debris. It begins to resemble a dynamic environment, even if an extremely slow one. Many of the objects that inhabit it share similar conditions: very low temperatures, volatile materials, long orbital periods, and above all, time. Enormous amounts of time. For years, these worlds were cataloged, measured, and classified, but rarely interpreted as evolving systems. Pluto changes that reading. If its surface can renew itself without fire, if landscapes can reorganize without catastrophe, then other distant bodies may be doing the same. Not necessarily in identical ways, not with the same intensity, but under the same principle. This forces a reconsideration of priorities. For decades, space missions were directed toward places where activity was expected to be obvious. Heat, liquid water, eruptions, geysers. Pluto met none of these criteria. And yet, it became one of the most transformative discoveries in modern planetary science. That alone should make us pause, because it suggests that our criteria for relevance may be biased. We search for what is fast, what is visible, what is immediate. But the most persistent processes may be the quietest ones. This shift does not affect only our solar system. It also reshapes how we interpret exoplanets. Many worlds detected around other stars are cold, distant, and seemingly inactive. Until now, they were often treated as secondary. Pluto invites us to look again, not as failed versions of Earth, but as systems with their own logic. They may not host life, but they may host processes. And processes are the foundation of any planetary story. This conceptual shift does not simplify our picture of the universe. It complicates it. It multiplies possibilities, expands the number of relevant worlds, challenges our observational limits, but it also makes our picture more honest. It reminds us that the universe is not organized for our convenience. Many of its dynamics operate outside our natural tempo. Pluto did not only expand the physical map of the solar system, it expanded the conceptual one. And in doing so, it left us with an uneasy feeling. The sense that we are only beginning to understand the margins. Not the margins of space, but the margins of our own ideas. And the closer we move toward them, the clearer it becomes that there is still much we have not yet learned how to see. At this point, the question quietly turns inward, not toward Pluto, but toward us. Because the deeper this understanding goes, the clearer another limitation becomes. It is not technological. It is not mathematical. It is temporal. Human perception is tuned to change that happens quickly. Events, peaks, moments that announce themselves. Science inherited this bias. We design experiments around detection, around contrast, around signals that rise above noise. Pluto offers almost none of this. Its processes unfold slowly, so slowly that they resemble stillness unless observed over immense spans of time. This creates a fundamental mismatch. We ask questions that assume speed. Pluto answers in patience. This does not mean the answers are vague. They are precise, but they are distributed. They emerge through accumulation, not revelation. This forces an uncomfortable realization. Perhaps many of our conclusions about distant worlds are not wrong, but premature. We classify too early, close questions too quickly, mistake lack of motion for lack of process. Pluto exposes this tendency. It forces us to recognize that time itself can be an active component. Not a backdrop, but a participant. A slow pressure that shapes matter, redistributes energy, and sustains change. In this sense, Pluto teaches a methodological lesson. Understanding some systems requires learning how to wait, not passively, but attentively. It requires long observation windows, careful comparison, the willingness to let patterns emerge without forcing conclusions. This is difficult, because modern science is optimized for results, for clarity, for progress measured in short cycles. Pluto does not cooperate with that structure. Its story unfolds over intervals longer than careers, longer than missions, longer than institutions. And yet, it is no less real. This creates tension between how knowledge is produced and what knowledge sometimes demands. Pluto sits directly in that tension. It does not accuse, it does not dramatize. It simply exists at a rhythm that exposes our impatience. This realization has consequences far beyond planetary science. Climate systems, ecosystems, galactic dynamics, all involve processes that unfold slowly yet decisively. Pluto becomes a reminder that not all important change announces itself. Some change whispers, and if we are not listening on the right timescale, we miss it. The challenge, then, is not only to build better instruments, it is to cultivate better attention, to accept that understanding sometimes means aligning ourselves with rhythms we do not control. Pluto does not rush us. It asks us to slow down, and in doing so, it quietly reshapes what it means to truly observe. By now, Pluto no longer functions as a mystery to be solved. It functions as a reference. Not a reference because it provides final answers, but because it reveals where our previous framework breaks. For a long time, planetary science advanced through clarity. Clear causes, clear effects, clear categories. Pluto refuses clarity of that kind. And in doing so, it exposes something important. Our categories were never universal. They were convenient. They worked well for fast worlds, for hot systems, for environments where change announces itself. Pluto operates outside that comfort zone. Its activity does not arrive as an event. It arrives as consistency. This forces a methodological shift. No longer can we rely solely on dramatic signals. We must learn to read coherence, patterns that persist, structures that remain balanced, processes that repeat quietly over immense spans of time. Pluto demonstrates that stability can be dynamic, that equilibrium does not mean stagnation. This realization alters how we define importance. For decades, importance was tied to intensity, to speed, to visibility. Pluto undermines this logic. It shows that a world can reshape our understanding without erupting, without glowing, without demanding attention. It does so by remaining itself. This has practical consequences. It influences which missions are designed, which worlds are prioritized, which data sets are preserved, and which are ignored. If slow systems matter, then observation strategies must change. Longer timelines, extended monitoring, patience built into institutions. This is not an easy transition. Modern science is structured around momentum, funding cycles, publication pressure, short-term validation. Pluto does not align with this rhythm. Its relevance unfolds slowly, too slowly for quick confirmation. And yet, ignoring it is no longer possible, because once the framework shifts, it does not shift back. Pluto becomes a threshold, a point after which inactive can no longer be used casually, after which dead world requires justification, not because Pluto is unique, but because it exposed the limits of our assumptions. In this sense, Pluto changes the rules without announcing new ones. It does not replace one theory with another. It widens the field. It allows for multiple forms of dynamism, multiple evolutionary paths, multiple rhythms of change. This does not simplify the solar system. It makes it richer, more complex, more subtle, and more difficult to reduce to simple narratives. Pluto stands quietly at the edge of this realization, not demanding attention, not claiming significance, yet impossible to ignore, because it shows us that understanding the universe sometimes requires learning how to listen to what changes too slowly to be obvious. At this stage, the story begins to close without closing completely. Not because conclusions are missing, but because what has been revealed cannot be reduced to a single answer. Pluto has already fulfilled its role, not as a solution, but as a filter that separates what we assumed we understood from what we actually comprehend. Looking back, it becomes clear that nothing discovered there was entirely invisible before. The data existed. The signals were recorded. The anomalies were documented. What was missing was not information. It was readiness. Readiness to accept that some processes do not announce themselves. They do not arrive as events. They do not demand immediate attention. Pluto did not teach us something new about ice. It taught us something new about time acting not as a passive backdrop, but as an active agent, an agent that allows small, almost imperceptible changes to accumulate real consequences. This understanding reshapes how we interpret stability. Stable no longer means motionless. It means coherent over long durations. Pluto is stable because it changes slowly. This idea feels counterintuitive, but it is powerful. It connects phenomena that were previously treated separately. Geology, climate, orbital dynamics. When time becomes central, these divisions soften. The boundary between active and inactive loses its sharpness. Pluto does not require drama to be relevant. It does not require speed to be interesting. Its significance emerges from persistence. This has deep implications for the future of exploration. It is no longer enough to go farther or faster. Sometimes it is necessary to stay, to observe for decades, to compare patiently, to accept that some answers appear only with sustained attention. This form of science is not less ambitious. It is more demanding, because it requires humility and the acceptance that the universe does not operate on our schedule. Pluto placed us directly in front of this reality, and in doing so, it altered something fundamental. Not our technology, not our instruments, our expectations. We expected a dead world. We encountered a coherent one. We expected silence. We discovered rhythm. This shift in expectation may be Pluto's most enduring legacy. Because once expectations change, everything else follows. And so, without spectacle, without resolution, the story moves toward its final moment. Not as an ending, but as a pause. A deliberate pause, before we ask what it truly means to have seen Pluto this way. And now, as this journey reaches its quiet end, it becomes clear that Pluto's greatest revelation was never a single image, measurement, or discovery. It was a change in how we see. Pluto did not shout. It did not impress through spectacle. It did not demand attention. It simply existed in a way that did not match our expectations. And that was enough. It forced us to admit that we had confused silence with emptiness, slowness with death, distance with irrelevance. Pluto matters not because it is extreme, but because it is consistent, because it shows that dynamism does not always require intensity, that some processes reveal themselves only when observed long enough. By looking at Pluto, we did not only discover a distant world, we discovered a limitation in ourselves, the expectation that the universe should operate at our pace. But the universe has no urgency. Its processes are not designed for rapid understanding. Some require patience, others require humility, many require both. Pluto taught us that cold is not an ending, but a condition, that apparent stillness can hide coherence, that stability does not always mean immobility. Perhaps this is the deepest lesson. Not everything valuable is obvious. Not everything active is loud. Not everything important is close. Sometimes, what reshapes our understanding the most exists at the margins, operating slowly, without calling attention to itself. Pluto did not close a story. It opened a different way of reading them. After Pluto, we no longer look the same way at cold worlds, distant objects, or the quiet regions of the solar system. And perhaps we no longer look the same way at ourselves as observers. Because understanding the universe does not always mean moving faster or reaching farther. Sometimes it means learning how to stop, to look calmly, to listen to long processes, to accept that some answers do not arrive as discoveries, but as gradual understanding. Pluto did not place a final point. It left an echo of a question that continues to follow us. How many things have we overlooked simply because they were happening too slowly? And perhaps, within that rhythm we do not control, begins the next great chapter of our exploration.